Hi, good humans. Welcome back. Today I am going to discuss with you congruence criteria in triangle. Now, when we say that two figures are congruent, we're talking about a sequence of rigid motions that is going to map one figure onto the other figure. Now, what is rigid motions? Now, rigid motions are either reflection, rotation, or translation. Now, when we say reflection, we're talking about looking at the mirror at ourselves. We see a reflection of ourselves in the mirror. When we talk about a rotation, we're talking about reverse, reverse. And when we talk about translation, we're talking about slide to the right, slide to the left, crisscross, applesauce, yay. So let's get right into this. We have a symbol that we use to show that two figures are congruent, and that figure is simply an equal sign with a tilde over it. That is a symbol that we use to show that two triangles are congruent. Now, there are 5 congruent criteria, and I'm going to list them and demonstrate them to you. The first one is SSS. Now, what is SSS? SSS is side, side, side. That means all 3 sides of a triangle is going to be congruent to all 3 sides of the other triangle. Let's say, for instance, this is a side. Segment AD is going to be congruent to segment XY. Segment BC is going to be congruent to segment YZ. And that's another side. And the third one is segment AC is going to be congruent to segment XZ. So all 3 sides of the triangle, first triangle, is congruent to all 3 sides of the second triangle. All right? Now the second one is SAS. SAS is side, angle, side. Now, side, angle, side means that you're going to have 2 sides and an angle that's going to be in the middle. So the angle is going to be sandwiched, right? It's going to be the part in the sandwich, all right, the middle part, the meat, and the 2 sides are going to be the bread. Let's show you. So let's get rid of this side right here, the third one. Don't need the third side right now. So I'm going to get rid of it. All right, I'm going to get rid of it for you. So I'm getting rid of it. All right, but now I have here, I'm going to use a different color, and I want something bright. All right, an angle in between here, and this is an angle. All right, now you have side, angle, side, SAS. Now that SAS, see, it must be in this form. The angle is in the middle, okay? Where do you want to be? In the middle or on the back? Let's stay in the middle, okay? In the middle, on the back, in the middle, on the back. Let's stay in the middle. So the angle is in between the 2 sides, SAS, all right? Now the next one that I'm going to show you, the third one is simply going to be ASA, and that is angle, side, angle, ASA. Now I have here an angle and I have a side, right? And I need another angle. I'm going to put it right here, and I'm going to use 2 arcs, and I'm going to get rid of this side right here. I don't need this side because I'm demonstrating ASA for you. All right, ASA. Notice it's going in one format. So now you have 2 angles sandwiched, right, with the side in between. All right, in the middle, side is in the middle. Now, I must say to you, you cannot put the side here and have have it like that. It's not going to work. That would not what it would be. All right, so be careful there. Now the fourth one is AAS. Angle, angle, side. Now angle, angle, side. Let's deal with angle, angle, side now. So we have here an angle here, but we're not going to use the angle here, all right, because this would be ASA. So I'm going to get rid of this one, and I'm going to place it up here. All right. And that would be your angle, angle, side. AAS. All right? AAS. Now, one thing I must say to you is that AAS is also an extension of ASA. How is that so? Let's see. So if you have the two angles here that are congruent to these two angles over here, and we all know that a triangle has three angles, right? Then obviously if these two are congruent to the two angles over in triangle XYZ, then the third angle, which would be angle C, is going to be congruent, right, to angle Z. All right? So you have three angles now that are congruent. So now you, instead of having just AAS, you also can use ASA. So ASA and AAS are extension of each other. So I just wanted to point that out to you, okay? That they're extension of each other. Now the third one, the fifth congruence criteria is HL, which is our hypotenuse leg. And the hypotenuse leg only works for right triangles. So you have to have a right triangle there. Not drawn to scale, okay? You have your right angle there. And obviously because you have your right angle there, then the segment opposite the right angle here would be your hypotenuse. This is your hypotenuse, all right? And then this would be your leg, all right? And then you say this is your other leg. And you can use either one, but make sure they are going in the same format. You cannot use this leg with the hypotenuse and then over here use this leg with that hypotenuse. No, you can't do that, all right? Now, we have our 5 congruence criteria here. And in general now, we simply write that triangle, and we write this is our symbol for our triangle. Triangle ABC is congruent to, that goes my tilde, congruent to triangle X, Y, and Z. And that's how you would write it to say that these two triangles are congruent to each other. All right? Now, those are the 5 congruence criteria that you can use. But there are 2 congruence criteria that we cannot use. And I want to write it out, and I'm going to write it that we cannot use those. And as a matter of fact, let's write the word cannot use. The first one, AAA. You can't use AAA to prove that 2 triangles are congruent to each other. You can't. All right? That's not enough. All right? You have to use any one of those 5. And you cannot use, the second one you cannot use is SSA. You cannot use SSA. And the reason being that if, say for instance, let's show you. You have, let's use here. All right? Not drawn to scale, but S is there and S is here, and I have an angle here. All right? So I have my S here and my S here. What happened to the angle here? All right? You have to ask yourself that question. So you cannot use SSA because you either have to put the angle in between here to use SAS, or you are going to use the other segment over here and use that as your SAS, but you cannot do that. All right, you cannot use SSA to prove that two triangles are congruent. Be very careful there, because it must come together in one format also. And please do not write this backwards on any paper. That's an insult. Please do not do that. It's simply SSA. Okay, so this is all I have today for the 5 congruence criteria. We often use this to write proofs when we're proving that two triangles are congruent. And once you know these, then you can get right into writing your proof. When you're setting up your statement and your reason, you usually have your, at the end, you have your statement here that the two triangles are congruent to each other. And for your reason, you use one of these 5 criteria as your reason. Okay, I will do separate videos on those for you, and I will also talk about CPCTC, which is really other corresponding parts of congruent triangles that are congruent. And that actually, if coming from when we spoke about if we had an ASA here situation going on, ASA, we can then talk about either this other part that is going to be congruent to this other part in the triangle, where this angle would be your CPCTC, or if we're talking about an SAS situation, then if we have an SAS situation, we also can have another angle here that's congruent to the other, which is the part, or we can talk about a segment over here that could be congruent to the other segment. So usually after you've proved that two triangles are congruent to each other, you can talk about a CPCTC, where that P from the CP is going to be, it's written like this, you'll see CPCTC. This P is either going to be an angle or it's going to be a side. Okay? So that's what I have for you today. Please go ahead, hit that subscribe button, like my video, share it with others so that they too can be knowledgeable about congruence criteria in geometry, and they will embrace geometry and embrace proof much better. Because a lot of students out there are having phobia when it comes to writing proofs. Okay? See you soon, and thank you for watching. Bye now.